Today we're going to take our multiplying fractions in a different direction. One thing we're going to be talking about is something called scaling, which is kind of like estimating, thinking about your answer and what it could possibly be in conjunction with what you're actually multiplying it by. And then we're also going to focus more on just multiplying the fractions and even in word problems. So taking it to that next level. So here on the front, we have some examples about this scaling. And then we're going to actually just multiply. So when we're looking at our two fractions, let's think about and understand what it's representing. If I have 2/3, is that even a whole number? No, it's two pieces of a whole that's cut into three. And if I have 3/4, is that even a whole number? No. So I'm taking a part of a part. And what we do for scaling is we think about the product. Remember, the product is our answer to a multiplication problem. Is the product less than, greater than, or equal to what we're multiplying it by? Do you see we're comparing it to 3/4? Well, we know that if we multiply anything times 1, we're going to get the same answer. So think about this. Is it less than, greater than, or equal to 1? Because we know if we multiply by 1, we'll get 2/3. So is our answer going to be less than, greater than, or equal to? It would be less than, because we are multiplying by something less than 1. So what happens when you multiply a given fraction, so any fraction, by a factor less than 1? What will happen? What will happen to the product if you multiply something less than 1? The product will be less. I'll use a less than symbol for quickness. Less than 1. Right? Now, when we multiply fractions, we talked about before, when we did our area models and number lines, we discovered we can multiply straight across. So if we have just two numerators and two denominators, we can multiply that, and 2 times 3 is 6, and then 3 times 4 is 12. So our answer is 6/12. It's that simple. What about this example? So I have 7/3 times 3/4. So let's think, is the product going to be less than, greater than, or equal to 3/4? So we're multiplying this by 3/4. Is 7/3 less than, greater than, or equal to 1? That's going to help us decide which one is it. We'll look at our fraction. It's an improper fraction. That means we're going to have something larger than a whole. So if this is larger than 1, then when we multiply it by 3/4, it's going to be larger than 3/4. So it's going to be greater. It's because we're multiplying by something greater. So let's put this in a generalized statement. What happens when you multiply a given fraction, so any fraction, by a factor greater than 1? Well, the product, the answer, right? The product will be greater than 1 whole, right? So again, we just have a numerator and denominator, so we can just multiply straight across. 7 times 3 is 21. 3 times 4 is 12. Ooh, what kind of fraction is that though? Improper. Now remember, I showed you an extra way of making these improper fractions into bigger mixed numbers by dividing. This could also be as 21 divided by 12. It's exactly the same thing you're thinking about when you're trying to figure out how many wholes you could take out of here. So how many 12s can go into 21? Well, 12 times 2 is 24. So 2 is not going to work. So it's just going to go in one time. And then we can see our leftover pieces. So we can then see that we have 9 left over. So our answer is 1 whole and 9/12. Okay? Improper fraction answers need to be changed into mixed numbers. What about this one? This example, 3/3 times 3/4. Is the product going to be less than, greater than, or equal to 3/4? So what are we even multiplying times 3/4? What does that equal? That's 1 whole. So it's going to be the same thing. We're going to get the same answer. It's going to be equal. So what happens when you multiply a given fraction, any fraction, by a factor equals 1. What will happen? The product won't get smaller. It won't get bigger. It will be, if I can write and talk at the same time, it will be the same. It will be the same as the factor, right? Ooh, numerator, denominator. Let's multiply. 3 times 3, 9. 3 times 4, 12. Final answer. Done. Now, this was scaling. So just thinking about, okay, look at what I'm multiplying it by and how is it going to compare to what I have, right? Now let's look at some problems. And we have some story problem examples of different situations because, there's not just fractions. There's also mixed numbers and improper fractions. What do we have to do when we are trying to solve those? So Grayson lives 2 4/5 mile from the park. He's already walked 1 3/4 of the way to the park. How far has Grayson walked? So making sure we understand, we're doing 2 4/5 of the 1 3/4, right? When we have mixed numbers, the new thing here is we cannot multiply straight across. We cannot multiply the 2 and the 1 because there's fifths in there. We have to multiply all the fifths. If we just multiply the wholes, that's going to be a different value. It's not going to show all of the fifths. So how can we see all of the fifths? How can we see all of the fourths that are hiding in this hole? We can make it an improper fraction. So remember, improper fraction means that each of these holes is worth 5/5. So we can easily go, okay, 5 times 2, because that's how many times we have 5. That's 10. But we also have 4. So 10 plus 4 is 14. So we have 14/5. Now we can see them all, right? What about the fourths? So 4 times 1 plus 3, that's 7/4. So now I have my numerators and my denominators. I can multiply straight across. This is where our numbers will get a little bit larger and our multiplication skills are going to be needed. So off to the side, if you ever have a bigger number, go ahead and multiply it if you can't do it mentally, like our prior fractions have been. So 7, 8, 9, I got 98 as my numerator. Quite large, right? This is also when our division's coming in handy. Let's divide this to figure out how many holes. Now, you can maybe do that mentally, but I can also show this in my division format to see how many holes I can get out of here and think about 20. Well, I know 20 times 4 is 80, so I'm going to go with that because times 5 is 100. That's too big. So how many do I have left? I have 18 left over. I know I can't get any more because I have groups of 20. So my answer is 4, because my 4 holes, 18 left over, and 20ths. Looking back at the story problem, we need to get better at this. What is this value referring to? Not far. This is not telling me, is it feet? Is it yards? Is it milliliters? Is it all of those different types of measurements? But this one for far, it's miles. Sometimes we got to go back and look at our value of our numbers. It's miles. Okay? Now try this problem. So looks like we are in a different situation here with a mixed number. Jeannie has 2 3/4 yards of yellow ribbon. She uses a half of the ribbon. So it kind of sounds like subtraction. It's not. She didn't use half a yard. We're not taking away half a yard. She used half of this. So we need to figure that out so we can figure out how many yards did she use for the bookmarks. So that's going to be 2 3/4 of half. Really, it sounds correct if we say it this way. We know because of the community property that we'll get the same answer either way, but it's half of 2 3/4, right? Well, the half is just ready to go. I can see the numerator and the denominator. I don't need to change anything with it, but I can't see all the fourths to multiply. So we're going to make this an improper fraction. 4 times 2, 8, 9, 10, 11 is our numerator. Our denominator is 8. We can multiply straight across now. Let's see. Oh, denominator is not 8. Hopefully you caught that with me. It stays the same. It's 4. So multiply straight across, you get 11 eighths. That's what I was already thinking about. So improper. Now I'll do this one mentally. You could use the division, but 8 can come out of 11 one time, and there would be 3 left over out of 8. What's our label? Yards. We can abbreviate with OYD. Okay. So the big thing is if you have a mixed number, you need to make it into an improper fraction in order to multiply straight across. Oh, this is different. I have a whole number. Casey is 4 feet tall. His mom is 1.5 times as tall as Casey. How tall is Casey's mom? Okay. So I want 1.5 of that 4 feet. Now, we know that if we have a whole number, we could just do repeat addition, but I'm going to show you how to do the multiplication way. It's much quicker, and you're very capable. Mixed number, got to see all those halves. So it's going to be 3 over 2. And then we're going to multiply this by 4 wholes. Now, if I want to be able to multiply my numerators and my denominators, well, I need a numerator and denominator that equals 4. See, these are equivalent. So whenever there's a whole number, you can simply just put a 1 underneath it. 4 over 1 equals 1. If it was 5, it'd be 5 over 1. If it was 10, it'd be 10 over 1. Any whole number, you can just put a 1 underneath it to get a numerator and a denominator. Then you can multiply straight across. 3 times 4 is 12. 2 times 1 is 2. Ooh, a nice easy one. This goes in evenly. No leftovers. It's just 6. What's our label? Not tall. Feet. 6 feet. Okay, so whole numbers, put 1 underneath so you can multiply straight across. Mixed numbers need to be turned into improper fractions and multiply straight across. Don't forget your labels. Good luck story problem solving.